Hi everyone, very good evening and welcome back to Geeks for Geeks practice and another problem of the day discussion as well. Hi Madbar Joshi and hi everyone else who is present in this particular session. Hi Rishit as well. So today we'll be discussing yesterday's problem of the day, that was nothing but construct a full binary tree. So let's quickly jump into that problem. So I'll share my screen. Let me know if it is clearly visible to all of you or not. Okay, thanks a lot, Rishit, for the confirmation. So basically, we have this particular problem, that is construct a full binary tree. So in this particular problem, what will be given is we will be given two arrays. Okay, so the first array will be the pre-order traversal of the binary tree, and the second array will be the second array that will be given. It will be the mirror. Okay, so it will be given as the mirror. So we have to do what from the pre-order and the pre-order mirror. What we need to do is we need to construct the final binary tree. Is this much part clear? Like, you'll be given two arrays, if you can see here, right? So if we take this particular test case, let's say if I'll write this, so I have one, then I have two, then after that I have four, then I have five, then I have three, and then we have six and seven, right? If we have this particular array, so let's say this is the pre-array, right? And suppose we have the pre-mirror array. So pre-mirror array, if I am writing here, so if you will see this particular array right here, right? So we have one, then we have three, then after that we have seven. Okay, then what we have is we have six, and we have two, and then we have five, and then we have four. Okay, so one thing is for sure, right? One thing that I'm very sure about is that the very first guy of the mirror pre-order mirror array and the pre-order array, right? It will be the root of the tree. Please write yes in the chat. This is one thing that I'm very much clear about. Yes, guys, right? You agree with me that the very first guy is going to be the root of the whole tree. That is one thing, right? Now after that, if you will observe now, after that if you will observe, so let us assume that one is the root, right? Here you can see one is the root. Then if you will observe, right, so we can see here 2 4 and 5, right? We can see here that 2 4 and 5 is there. So if you will see 2 4 and 5 is there, and after that you encounter 3, so you can see that here also you have the 3, right? So if you iterate after one, if you like after the root, after the current root, if you keep on iterating until you reach the next guy in this pre mirror array, right? So you can see that this will be nothing but our left subtree, right? So 2 4 and 5 are going to be our left subtree. Is this part clear to everyone, guys? And similarly, if you will observe, right, if you will observe, so if you look for this particular guy 2, right, and you iterate in the pre-mirror array, so you can see here 3 7 and 6 are there, right? So you can understand one thing, that if 3 7 and 6 are there, right, so this tells us about something. Is this part clear? Right, are you able to understand the point that I am trying to emphasize on or not, guys? Right, to construct this, if we have to use the pre-order mirror array and the pre-order mirror array and the pre-order array, right? So you know that pre-order, the very first guy will be the root, right? Then the value next is what, this guy is going to be the left child, right? Until we reach there, and the value next to the root in the right subtree is going to be the right child. So this guy is going to be the right child. So is this much part clear to everyone or not? Right, you can see here that this guy 3 is going to be what, it is going to be the right child. So you can see here that from 3 7 6, right, so till this particular point you can see that we have the right subtree. So we have what, 3 7 and 6, right? Now if you will see that much more further, so obviously what will happen is, suppose that if 2 is the root, right, then in that case, before reaching 3, if you are here, so you can see that if 2 will be the root, right, then you can see here, right, if 2 is the root, then it if you will break it down further, so later on you will be able to observe that since this is a pre-order, so 4 is there and 5 is there. So obviously when you will break it down one step at a time, so you'll be able to observe that I think 4 will come as the left subtree, and 5 will come as the right subtree. Okay, so yeah, is this observation part clear to everyone or not? Please tell me, guys. Like, is this observation clear? Madbar is saying yes. What about others? Right. So until you reach this point, basically the idea was that if you just need to break it, right? You need to recursively break it. So you need to, but you need to loop here also. You can see here that once I was at the root, so I started from the next guy. So until this particular guy, you can see that if I keep on iterating and until I reach 3, all the people that are going to be there, they are going to lie in the left subtree. And similarly, I can see that the rest of the guys are going to lie in the right subtree. So that's how I can decompose this particular problem. Is this part clear? So this much part 3, 6 and 7, you can say this will lie in the right subtree. So I can call for that, and recursively the same process can be followed. So here I will assume that 2 will be the root, and then further on I'll keep on following. So is this idea clear or not? Please tell me. Okay, you are saying clear, right? So that is how we need to solve this particular problem. This is the main approach or the idea for generating the code of this particular problem. Okay, so if you will see now, what I need to have is int. I will have p. Okay, p will be starting from 0. This will be the index in the pre-order, like what I can say, pre-order array, right? Because I need to have two indexes, as I already said. So I'll have one p index for this pre-order array, and let's say I have pm. So pm will be the index that I'll be using in the pre-order mirror array. Is this part also clear to all of you, guys? Okay. To do this, all nodes in the tree are unique, right? All nodes in the tree are unique. It can be unique, it cannot be unique. It is not necessary that it will always be unique. You can have repeated values also. It is not mentioned anyway that you cannot have you need to have specifically unique values, because it is more dependent on the indexes side of things, right? But to be honest, I don't think that it will clash. Okay, Rishit, it will not clash. The test cases will be made in such a way, like actually it is a perfect binary tree, na? Like this is a perfect binary tree, right? So the thing that you are saying, it will not clash. It is not going to clash in such a manner. Okay, right. Now in this case, you have the p and you have this as let's say pm index, right? Then I will say that, okay, what I'm going to return is I'm going to return a recursive function. Okay, and let's say in that recursive function I'll pass the pre-order array. Okay, I'll pass the pre-order mirror array also, right? And after that I will pass what, I'll pass the pre-order index, let's say. Okay, and I'll pass the pre-order mirror index. Initially I'll pass 0. I'll pass what, size minus 1, because actual indexing will be 0 to n minus 1 base, right? And I will also pass the total size of the array, because I want to check with that also, right? So what this is going to return is, this is going to return the root always, right? So now let's write this node and star. Let's say we have the recursive function again. So we'll write int pre-order array here. Okay, then int will write what, pre-order mirror array. Okay, then we will have int p, then we will have int pm, then we will have what, then we will have the int left index, let's say. Okay, because we are going to partition it, and we are going to have, let's say, the right index. Okay, and then we are going to pass the size also. So is this much part clear? Because initially what I'm going to pass is, now I'm going to pass this whole segment here. So I'm going to pass the range as L to R, then the range will keep on decreasing, right? And once the L crosses the R, that is when I should be stopping. So I hope that you have idea about this much part, right? Is it clear? Okay, guys. So this much point is clear to everyone. Now, when should I stop the traversal, right? That is another thing. So suppose that if it happens that my pre-index, right? If my p that is pointing in the pre-order array, if it is greater or equal to the size, then I can stop. Or when can I stop? Or suppose that it happens that suppose L is greater than R, then also I should stop, right? So in that case, I will return null, because there is no further node that will be left. Otherwise, what I will do is I'll say that, okay, the current guy that I am at, okay, the current if suppose P was here, right? So I will declare, I'll say that, okay, this is going to be the root. Okay, so I will make that one as the root node. Okay, current root. Okay, and then I will have to do the traversal and all that stuff, right? So what I will do here is, first of all, I'll make the root. Okay, so node star root is going to be what, is equal to nothing but new node, and then we will pass here what, we'll pass pre and p, we can pass here, right? P, and then I think that we can just pass this thing, right? So yeah, we just pass this particular thing, and after that, suppose that if also one more thing that I should do is I should do p plus plus also, right? So yeah, this is one thing that I should be doing, because I should increment the value of p here, right? After this particular point, we should also check. Suppose that if L was equal to H, right? So if it was the only node, then I will just return this particular root. Are you getting my point, guys? I hope that you have solved some of the three questions. Right, I will just return the root part. Is it clear? Suppose that if we reach the end cases where L and H are same, so if we reach the leaf node, then you will just return the root. Okay, that is what you can do normally. But otherwise, if that is not true and we are going to iterate, so what we are going to do, we are going to iterate. So let's say we have a loop int I starts from, let's say we have a loop, let's say j starts from L, okay, and j is going to be lesser than equal to the R, and then I do a j plus plus, right? So I will be iterating here, right? And when I'm iterating, when I'm going to iterate, so when I'm going to iterate, so what is the condition when I will break? I'll say that, okay, if it happens that the pre order of pre, okay, if the guy in the pre-order array is equal to, so let's suppose I'm at this 2, right? So see, if my p has, if my j is iterating, sorry, so if my this thing is iterating, if I'm in my pre-order array, yeah, so if suppose that I am at this particular guy too, right, my p is here, so my j is going to iterate here, j is going to iterate here, j is going to iterate here, but the moment my j reaches here, that is when I will break. Is this part clear to everyone? Please let me know, guys, yes or no. Are you clear with this part, guys? Please tell me. Right, so the moment it happens that in the mirror array, pre-order mirror array, if there's any jth guy that is equal to the pre-order of p, then I am going to simply break the loop. Is this much part very much clear to everybody? Yes or no in the chat, guys? I think that it's clear. Okay. Now another thing is that I'm going to break. That is fine. But will I always keep on running the j? No, because suppose I have a segment length. So here you can see that r value will be initially here, right? So in that case, you will keep on iterating. You can keep on iterating, and you will break here. But it sometimes it might happen that suppose that r value is here, and your j keeps on iterating and it crosses, right? It might also happen. So for keeping that under a check, I'll say that j should be lesser than equal to r. If j is lesser than equal to r, or you can say that if I am passing, na, so if the L if I'm passing, so if the j is lesser equal to r only, then only I will take consider those indexes of the second array, right? So in that case, I'll say that, okay, what will be the left child? The left for the left child, I'll say that I'll simply call the recursive call, okay. And what I am going to do is I'm going to pass the pre-array, right, and I'm going to pass the pre-order mirror array as well, right? So mirror mirror array. Just give me a second. So I'm going to pass the pre-array. I'm going to pass the pre-order mirror array. Okay, then I'm going to pass what? I'm going to pass the index. So what will be the index in the next iteration if I'm going to pass the indexes, right? So you can see here next time if I'm calling now. So if I'm calling if I'm calling for all those guys, so what will I pass here? Anybody can tell me. See, initially if my j starts from where? I think j is starting from this point till this point, no? Just give me a second. So we are iterating, right? So if you will observe, so see, initially j is here, right? Then j is here, j is here. So you can see initially I'll be passing this particular guy, so I will call it for the left side. Okay, so initially from where till where am I going to call? So from j till the right, this is my left half, so I'm going to call for the size, right? And whenever this is how I'm going to build my what you can say, this is how I'm going to build the left subtree. And how will you build the right subtree? So in that case, you will say that, okay, roots right, okay, you will call for it, and don't worry, you will understand it once I complete the writing part. So yeah, you will call the pre and you will call the mirror array here. Okay, and what are we going to pass here? You have to understand this particular thing, right? So if you can see here, right, if you will see here, let's suppose that you had this particular array, right? So your p was here, okay. Initially, where was your L was here and R was here, right? So in this case, what is going to be the left half and what is going to be the right half? That is something that we are concerned about, right? So initially, if we have the, let's say, j guy as j guy is here, okay, and the r guy is here. So suppose we are calling for this much part. Now in another thing is, what will be the right half, right? So for the right half, what we will call for is, we'll call from like you can say L plus 1, right? So from L plus 1 till the j minus 1, that is what we can say that will be our right half. Is this part also clear? So we are going to call for what? L plus 1, okay, till the j minus 1, you can say that will be our that will be called for the right subtree, and we'll pass the size here as well. And once our tree has been once this is made now, so we will just return it. Is this part also clear? Just give me a second. I will do one thing. I've done one mistake. I should This loop will be here, okay? And if the j value is lesser than equal to the right, okay, then I'll tell you what I am doing. Just give me a second. So in this case now, what is happening here? Just give me a second. I'll tell you. So see, initially your p was here, so you have made one as the root, right? Then you find the breaking point, right? Then you are trying to find the breaking point. So once you keep on iterating and you find that, okay, this is what, let's say this is the jth guy at which you have broken, right? So now can I say one thing here very easily? If you have this as the L, suppose this was passed as the L and this was passed as the R, right? So in this particular case, if you have this as L and this as R, right? So for the right guy, if you will observe, right? So this is also L and this is also R, let's say, right? So in this case, you can observe one thing, that what is going to be my left, what is going to be in my left subtree. So in my left subtree, I can say that I will call for what I will, if I'm calling for the mirror, right? So yeah, suppose I'm calling for the mirror part. So if I am calling, so you can observe one thing. Let's say this is the breaking point, right? So what will I be calling for? So you can see that from this point till this point, all these guys are going to lie in my left, right? So the left half. So that is why I'm calling from j till r. And if you will observe what I'm calling for the right half, so what I'm calling for the right half is from this particular point, I think from L plus 1 till j minus 1 I'm calling. So this is my right half. So is this idea clear to everyone or not, guys? Is it comfortable? Should we keep L and R for pre and you can keep a separate L and R, but it is not that much necessary, right? So that is how we will update the root, and then I can simply return what, return the root here. So is this much part clear up till now, guys, or not? Please tell me. Or if there's something that you are not clear with, then please let me know. Rishit says he's clear. Okay, it says J. Have I done any mistake here? Okay, I should declare J outside the loop. Okay. So yeah, int J I will declare here. Just give me a second. Let's try and run it. Is it clear to everyone? You could have declared, but it is not that much necessary. Okay, what is the mistake in this part? Have I passed something less? Yeah, I have not passed the P and the PM also. No, I think so. I should pass the P and the PM as well. Okay, let's see what happens now. Okay, guys, now let's try and see how it works. Okay, L is equal to R. I should write here. Sorry, not low is equal to high. Any other mistake? Pre-order. Okay, I'm passing this array. I'm passing P, J, R. Mm, is there any other mistake that I'm doing here? Before this, so I think I have missed some brackets here and there or something. No, I have not missed any brackets. In which line it is giving error? Line number 54, 55. So we call the recursive function, okay? We pass the pre, ppm, j, and r, and the size also. Is there anything less that I'm passing? I don't think so. Or am I missing any colon somewhere? Okay, yeah, there's an extra minus here. Sorry. Still, it is giving me an error. 54 to 48 in this part. There is a minus after a. After there is a minus. Which part am I making mistake? Yeah, there is an extra comma also here. No, that is another mistake. Sorry for that part. It does not work. Okay, so it is not working. Why is it not working now? Now the logic is failing after changing the code. So if they are equal, then I am breaking, right? So I'm iterating from L till R. So this is fine. If I had only one node, then I'm just returning. Otherwise, I'm iterating from L till R. And suppose that if it happens that pre-index of P is equal to pre-mirror of J, then I need to break. That's fine. And that is how I'm breaking from the loop. So that's totally fine. And if the L value is lesser, if the J value is lesser equal to the R value, then I'll call for the left and the right. So that is also fine. So I'm calling for this and this also. Yeah, so I'm passing the pre-order mirror also. Okay, mirror index also I'm passing. Okay, so yeah, this is fine. Then what am I passing here? Am I passing any extra thing? Okay, so I think what I need to do is any changes that I make to the pre-order index now, they should be reflected in the final part. So I think I need to pass an ampersand here, and I don't need a pre or pm here because I'm not using it, I think, right? So I can avoid sending this pm there. Possibly that is one thing that I can try to do. But okay, so yeah, let's remove this from here because I was not using it, so I think that I don't require it. In the actual code I was using it, but I when I had written it, but since I don't think I'm using its logic anyway, so I don't require it. Okay, so any changes that I'm making to it now, because any changes that I'm making to it, it should be reflected in all the calls also. So that is why I need to pass it by reference. So that is one mistake that I was doing. Now, is it clear to everyone, guys? Please let me know yes or no if you are clear with it. Can we do a dry run with a smaller example? Yeah, we can do a dry run on this particular same example only. So, what I will do is, no, let me just do one thing. Let me just erase this much part. Okay. So, if you will see here in this particular point of time, right? If you will see here, so yeah, let's say we have this particular array. So initially what I'm passing is the p. I think I'm passing it as 0. Yeah, and I'm passing this as lnr, right? So suppose I have my lnr, right? For both arrays you can consider that. Now initially my p is there, so I make one as the root node. Okay, once I have made once I have made this part, so I will do a p plus plus. So my p moves here, right? So now my p is standing at this point. Right now, since it is standing at this point, so with the help of this, now it will always tell me the root. Are you getting? The pre-order array is going to tell me what? It is always going to tell me the root. Okay, are you getting this point? That is very much important. So now once I have it, so I am iterating, let's say, a j loop. Okay, I'm iterating a j loop in this particular array, and if I'm iterating a j loop in the second array, you can observe. So j will iterate here, here, and here, and then since the p of like prefix array of p is equal to the prefix mirror array of j, then that is when I need to stop, right? So at this particular point my j will stop, right? So this is where my j stops. Now after that, since my j is stopping here now, so what am I going to call for? So in this case, if you will see, so let's say my j stops somewhere here, right? So now I will call for what? I will call for the left. I'll call for the left. Okay, and I'll also call for the right. So I will do what? I will generate the for the current route, I will generate its left as well as the right. Are you getting this point? So when I will do the next call, so this is where my p will be. And if I am doing what? If I'm doing this, so this is where my p is. And if I'm calling for this particular part, what you can say, for this part, when I'm at this particular current guy, right? So I'm calling for the right half and the left half. So you can if you will see, so from in this particular array, if I'm calling, so you can see that from j till r, right, I'm having my left subtree, right? So that is what I'm passing, and that is why I'm passing this. And from L plus 1 till J minus 1, I'm having the right subtree. No? So that is what I'm passing there. Is it clear now, Rishit? Much more clear? Because you are not going to touch this particular array, because this array is always going to tell you about the current root. So that is what we are doing here. Is it clear now, guys? Please tell me yes or no. If you will do a further dry run, if you will do it the dry run for the rest of the tree, then you will understand it better. But I hope that you have got the intuition for it, right, guys? So if you will see, since we are running a loop, so it can take order of n times. So for one node it can take order of n times, so the overall complexity will be n square. And since we are building up the tree, so the space complexity will be order of n. Now let me do one thing. Let me just provide you with the code as well. Just give me a second, and I will write give you the code also. This this regular class? Yes, Mr. Mojo, this is a regular class. It happens at every day at 6 p.m. Okay. Yeah, so I have shared the code with all of you as well. I hope that you have understood this problem, right? Make sure to solve the today's problem of the day. If I'll search again, let's say if I'll search GFGP problem of the day, right? So today's problem is also very interesting. The problem of the day for today, it is maximum identical balls, right? And it's based on the concept of some normal mathematical logic. So try out that problem, and we'll discuss it tomorrow. Okay. With that being said, thanks a lot everyone for joining for today's session, and I will see you with another problem of the day tomorrow. Till then, keep coding. Make sure to hit the like button, and thank you for joining for today's session, guys. Thanks a lot. Thank you, Madbar.